This is my fourth video in my Color and Light series, and it's about colored light. And please subscribe and check out my book on Amazon, Ellen's Guide to Color, Light, and Shading. White light, like sunlight, is made up of many colors that we see when it hits a prism. When white light hits a blue surface, for example, some blue rays, maybe with a little green and purple, reflect to us so the surface looks blue. And depending on the translucency of the surface, some of these blue rays are transmitted through, but the rest of the rays are absorbed by the surface. Now, white light can reflect most light rays, while black surfaces absorb light. Since light is energy, absorption by the black surfaces can make them hot, depending on whether they retain that heat. And we see light, not surfaces. And how do I know that? Because when the light is red, the surfaces look red. Rainbows separate into the colors we see with a prism. So with a primary rainbow, we see red on the outside and violet on the inside. For a secondary rainbow, we see the opposite, red on the inside and violet on the outside. The sky is lighter within the primary rainbow and darker between the two rainbows. Here we have red, yellow, and blue squares under white light. With yellow light, the red becomes red-orange and the blue becomes blue-green. All of these blocks now have some yellow in them, so they look more unified. Similarly, with blue light, the red becomes red-violet and the yellow becomes yellow-green, so there's some blue in all of them. When does colored light look colored? Well, it has to do with color adaptation. These incandescent lights look very yellow from the outside, but we know that if we're inside, it looks nearly white to us. But it will affect how we paint, and so it's important if your painting is to be viewed under incandescent light, you should probably paint under that light. When colored light is so strong that we can no longer adapt to it, it changes the color of things. This red light makes the clouds pink and the sky violet when this red combines with the blue of the sky. The red enhances analogous warm colors like the skin because the red has so many orange rays that it can reflect to us, so the color looks saturated. But red dulls complementary colors like green trees. Red light has almost no green light in it, so the trees can't reflect green light to us, so they look black. How does the sun become orange? Well, at noon, the sun, let's say, hits the earth perpendicularly. Some of the blue rays are deflected by the air and make the sky look blue, but most of the sunlight that reaches the earth is still white with maybe a little yellow. At sunset, however, it travels through much more air, so it starts white, then becomes yellow, and as it loses more and more blue light, it becomes orange. And that's what we see at sunset. It also becomes low intensity because it has lost all these blue-violet rays. Colored light is weak or low intensity compared to the sun at noon because it's missing cool colors like blue, violet, and green light. We can see a decrease in light intensity with distance, and it decreases in a specific way. If we had a light source that hits this yellow square 1 foot away, we get a light intensity that I'm going to label as 1. At 2 feet away, the square enlarges so that we get the same light spread over a larger area, and the intensity is now 1/4 of the original square. And at 3 feet away, the light intensity is only 1/9 of the original. Since snow reflects the color of the sun, we see that it is yellow and orange here. But why is it brown over here? Part of it is due to light decay. It gets less sunlight, but also it's reflecting the blue skylight, which dulls the orange. Now, distance is hard to determine when the light intensity is low. It's hard to know how far away these trees are, but we have a better feel for how far away the sun is. And the other point I want to make is that the green trees no longer receive green or blue light to reflect to us because this is mainly orange light. And as a result, we see little texture, detail, and the trees look very dark. Colored light adds drama and excitement to a picture, so it's worth knowing how to use it. We tend to adapt to colored light if it isn't that strong, like incandescent light. But when it is so strong that we can no longer adapt to it, it changes the color of things. It enhances the saturation of analogous colors, and it dulls complementary colors. Colored light is also low intensity, so we see light decay. Light areas of objects reflect the color of the light, while shadows are tinted with the color of the sky. My next video is about reflected light.